Welcome to the lectures on problem solving and programming in C. This is lecture 25, and the title of the lecture is maximum and minimum in a list. In this lecture, we will see how to find a maximum element or a minimum element of a list. Okay. So in previous lectures, we have solved similar problems where given a sequence of elements um, to compute maximum element or minimum element. But the only difference is there we are not storing the elements in a list. The elements are taken one by one and discarded. Okay. But in this case, we have flexibility to store the element. And first we will store the element, then we will compute the maximum and minimum. Right. The first thing is we will see two versions where maximum and minimum, maximum or minimum. See, we will first see for a maximum element. Minimum element can similarly obtain. So first we will see how to write an algorithm to compute the maximum element of a list. Okay, and then we'll also see how to write computing a maximum element as a procedure, separate procedure. Right. We'll also see how to compute second maximum element. Right. So like before, we need to read the list of elements and then display the maximum element. This is an algorithm. List max. List max. Input a list of n elements. Integer numbers. N where n greater than 0. Right. Output maximum element of the element of the list. Just okay, begin. Begin. So we need to read n value. We need to read n value. So input n. Input n. So if input validation, if n less than or equal to 0, then output invalid input. Stop. Okay. Otherwise, if n is valid, then we need to read the input, right? This is for reading. Read list elements. Read list elements. This is a comment, not part of the program. Okay. Write output. Enter the list element. N integer numbers. So let us don't do this. So what we will do is we'll write for loop for I equal to 0 to n minus 1 do input. So we need to declare here L of n, ln, right? Declare L of input, L of I, and for, right? So what is the logic for C? We will process the element one by one, and then if every time at each iteration we will maintain the maximum element seen so far. Suppose if we have only one element in the list, what will be the maximum? The first element is the maximum, right? So max equal to L of 0. From then onwards, the maximum can be L0 or so it can be somewhere else also. We need to compare with other elements also. So at each iteration, from now on, we will compare with L1, the maximum. If L1 is maximum, what is the meaning? Maximum has to be L1. So we will compare maximum with current maximum with the next element. If the next element is maximum, then we will update the maximum. Okay. So we need to compare for I equal to 1 to n minus 1 2. So if L of I is greater than max, current max, okay, do then max equal to L of I. Whenever you get a new maximum, you will update the maximum. Okay. By the time you process all the elements, maximum will contain the maximum element. So output max. End. Okay. If you are computing for a minimum element, what will be the change? Change will be here. Min equal to L of 0. Here min, if it will be less than here, if L of I is less than min, then min equal to L of I. Then output min. If you are computing a maximum element, you need to run the blue lines of code. If you are computing for a min, if you are writing algorithm for minimum element, you have to replace these statements. This statement with this, these two statement with this, these two statement, this if statement with this statement, and then basically we need to replace this statement with these statements. Only comparison is there is a change in the name of the variable max to min, and then only difference is the maximum greater than symbol will be replaced with a less than symbol. Otherwise, the logic is same. Okay. Let us try to translate this to a program. AI list max hash include tdio.h. Int main is the function. So by default return 0. This is my empty program, and then there is a input n. So int n printf enter number of elements, scanf %d %n. Okay, then input validation if n less than or equal to 0 0. So we are doing input validation. Then input is invalid, print invalid input, then stop. Otherwise, the reading of the input, we need to declare the L of n for int I equal to 0, I less than n, I plus plus, printf, enter the element L %d I scanf %d ampersand L of I. Then int max equal to this. I'm translating this. Int max equal to L of 0. Max equal to L of 0. Then there is a for loop here. There is a for loop for I equal to 1 to n. For I int I equal to 1, I less than n, I plus plus. Then there is an if loop here. there is an if condition. If L of I is greater than max, we got a new maximum. So max should be updated. Max is equal to L of I. Then display max. Printf max equal to %d. So let us save it and compile. There are no syntax errors. Number of elements, let's say 10. L0 will be 10 minus 20, 100, 200, 300, 25, 20 minus 10, 21, 9, 2, 3, 4, 90. So maximum is 9234, right? Maximum is 923. Like that, it will display, reads the number of elements, and then it displays the maximum of the elements we have entered. So little bit beautification we will do. So the number is coming immediately after the bracket. So I will add a colon here. Insert colon. Okay. ECC. Number of elements 8. Let's say 1, 2, 3, 4, 5, 6, 7, 8. 8 is the maximum. Okay. So if I want to compute the minimum element, I just need to display less greater than this greater than symbol should be replaced with minimum. The program name I'm not changing, just to show that it does work. Okay. Let us compile this. Number of elements 8, 1, 10, minus 20, 23, 45, 67, 78, 8. Okay. So minus 20 is the minimum, right? Minus is a negative value, all are remaining are positive. So just by just changing the greater than symbol to less than, the algorithm, the program actually computes the minimum element. Let us convert it back to maximum element because the program name is, we have named it as maximum, right? So let us, so now the question is, this is an algorithm, right? So, but many occasions you have, we need to compute the maximum element, but every time writing the logic will be code repetition. So we can write this in as a function. We'll write a procedure now. Procedure. So what it takes is procedure max list max, get list max. So what can we name it? Get list max. So what will be the list? L of 0 to n minus 1, n elements of the list. That's it. Okay. Then input a list of n elements as an argument. Output returns, this function returns the maximum element of the list. Right? To begin. So let us move to this. So we don't need to read input, right? Input will be read by the user whoever calling this function. We just need to compute the max. So max is equal to L of 0. Then for I equal to 1 to n minus 1 do minus 1 to if L of I is greater than max, then max equal to L of I. Okay, and if and for, right? So here we will return the maximum. Return, instead of printing, we are returning max. Then end. So user, whoever is calling this function, will read a list of n elements, and then he will pass the list to this function. List to this function, list and also the number of elements. We should also pass n and list of elements. Then this function computes the maximum of the list and returns the maximum. It doesn't modify the list elements. Okay. Let us use this function instead of earlier code. List max. List max using a procedure. VI. Everything is same, but what we need to remove is this logic will be removed. Okay. Input validation, we have done the read the input n, input validated, read the elements, then we can have to call the function max equal to get list max of what we need to pass. We need to pass the n value and l value, list size and the l. So remaining thing is same. So but we need to write this function. What is the return type of the function? Integer, right? Returns an integer which maximum, which is integer type, right? Get list max. Okay. Then so this is how. So what is it? It has two arguments. One is n. What is the data type of n? Int. And then another one is a list. Int L something. We don't need to specify the length here. This is how you declare. This is a prototype of the function. Integer n and then followed by it takes an array list of n as an argument. This is how you declare. Okay. So int max equal to L0 for int I equal to 1. So I less than n, I plus plus. If L of I is greater than max, then max equal to L of, then return. So this function we need to define the prototype. The prototype we need to declare the above the main function. So we'll declare here. We can write like this as it is, or we can even remove these arguments also. We can remove these arguments. They are mandatory, not mandatory. PCC. Let us compile this program. Successfully compiled. Let us run this program. The number of is 10, 8, 7, 2, 3, 4, 2, 2, 3, 4, 7, 8 is the maximum. Okay. 8 is the maximum. This way, we can compute the maximum element of the function using a procedure. It's a good practice to write this maximum minimum functions as a separate function. Okay, if you are writing a maximum list max minimum, so this less than greater than will be changed to less than. That's it. Rest of the logic will be same. So let us see the remaining problems. So we have seen the maximum element as an algorithm, maximum minimum using a procedure. Let us see how to compute second maximum, second minimum. Okay, let us try to modify this. So what we need to maintain is, we need to maintain not only maximum, we need to maintain the second maximum. Second maximum. Second maximum. S max. Max is equal to L0. Both should be assigned to maximum. If L of I greater than max, then what we need to do? Max is updated. Before updating max, if S max L of max is since we are getting a new maximum, then control Z, we are getting a new maximum, then max will be updated to L of I, but S max will be max. Sorry. S max, second max is equal to max. Previous max will become now second maximum, right? And then new maximum will be maximum. Otherwise, else, if even this condition is not met, it can happen that else if L of I is greater than S max, then S max is equal to L of I. And if print max and S max. Okay. See, what we need to do is we will compare every time we will update the maximum if there is a new maximum. Every time we will update the second maximum also if you find a new second maximum. Okay. So if a new maximum is found, what happens is earlier second maximum will become the second maximum. The current maximum will be maximum. That is why max is updated. Otherwise, so basically we didn't find a new maximum, but what happens is new element can be more than the second maximum. So that is why we are comparing L of I is greater than S max. If that is the case, we are updating the S max. After this repeated statement, we are just printing the max and S max. Let us try to modify the function. Yeah. We are updating int S max is equal to L of 0, right? Here, one statement S max equal to max equal to L of I, else if L of I is greater than S max, then S max equal to L of I, right? Print of max equal to d comma S max equal second max equal to %d max comma S max. Okay, let us run this program. Test max. Okay, 8 numbers. Let us give one numbers from 1 to 8. You see here, maximum is 8, second maximum is 7. Like this. So these programs can be modified to get the maximum, second maximum. So see, basically we cannot write a function which returns both maximum and second maximum. The function returns only one value. So if you want a maximum, you write one function. If you want a second maximum, you write another function to come get the second maximum. Okay. Second minimum can be similarly obtained. Similarly, only difference is instead of greater than here, it will be less than. It will be less than here. Okay. I will stop here. Thank you.